Okay, Assalamualaikum warahmatullahi taala wabarakatuh. So today we are going to study the last subtopic. Okay, for your preparation for ujian selaras 1. Okay, so let me set up first. Okay guys, so this is the topic that we are going to study today. So I just want to focus on the example of process that you should know that can be related to the homeostasis. So basically, there are 4 of them. Okay, body temperature, blood sugar level, the partial pressure of carbon dioxide, and the last one is the blood pressure. Okay, so before we go to the 4 example of this, okay, we need to know what does homeostasis means. I'm sure all of you have been familiar with this term because I think you have studied this term since you were in Form 1. Okay, so let just revise what does it mean. Okay, so homeostasis is a regulation of a physical and chemical factor of internal environment, okay, within a normal range for the cell to function in optimum condition. So I would say homeostasis is the process to maintain internal environment so that the function can function in the optimum condition. Okay, so we go for the first example. Okay, how homeostasis take place to regulate body temperature. Okay, so here they give you a few example. Okay, so let's read what does it say. Okay, maintaining body temperature at a fixed range is important so that the cell metabolism reaction that are catalyzed by enzyme occur at optimal level. Okay, temperature that are too high will denature the enzyme. Okay, so we know that the optimum temperature is 37. Okay, 37 degrees Celsius. So if you have the temperature higher than that, okay, this will make your body having fever, and also your enzyme become denatured. Okay, but when the temperature are too low, okay, so this will slow down the enzyme activity. So the next one, okay, the change in body temperature are detected by thermoreceptor. Okay, so this thermoreceptor you can find in two places. The first one is in the under the skin. Okay, and the last one is in the hypothalamus of the brain. Okay, so this figure show the regulation of body temperature by different effector. Okay, when the body temperature increase beyond the normal range. Okay, bear in mind effector. Okay, in this regulation, it involve various factor. For those who don't know, effector is the one that will produce response. Okay, so let's study in detail. Okay. So when this is the first example, okay? This is the first example where it say that when the body temperature rise above a normal range, okay? For example, you are doing exercise, okay? When you are jogging, for sure your body temperature will rise, okay? So body temperature will rise above normal range, okay? So this change, okay, this change in body temperature will be detected, okay, by thermoreceptor that can be found in the hypothalamus and also, okay, under the skin. Okay, so when it has detect this stimulus, okay, so these two things, okay, thermoreceptor, okay, in hypothalamus and the skin will send the nerve impulse to the brain, okay, to the brain. Okay, so why? Because the brain will interpret the information. Okay, so once the brain interpret the information, the brain will send another impulse to the effector. Okay, why effector? Because effector is the one who will produce the response. So here you can see this is what we call that the effector that involved. Okay, so how many? One, okay, two, three, 4, 5, 6. So there are 6 effector there is 6 effector that will involve to produce a response. Okay, so we go one by one. So when we have a higher body temperature, okay, the brain will send, okay, the nerve impulse, okay, to the first effector, which is erector muscle. Okay, so this is our hair. Okay, kita punya, for example, ni bulu tangan kita. Okay, so this is our hair, and then there is a effector muscle, okay, that is connected to the hair. So the brain will send the nerve impulse to the effector muscle so that it become less stimulus. Okay, when it is less stimulated, okay, so they do not constrict. Okay, they do not constrict. Dia tidak mengembang lah. Okay, so when it is not constrict, so your hair will be lower towards the skin surface. So it means that your hair will lie down. Dia akan jatuh ke bawah. So what does it mean? So as the result, a thin layer of hair trap. Okay, a thin of layer of air is trapped between a fine hair. So heat can be released quickly. So as you can see here, when the hair lies down, okay, so this will give a chance, okay, for the heat energy that trapped in our body to be released out. Because we know that when we are doing vigorous activity, we are producing so many heat energy. That's why our body temperature rise. So in order to release, okay, the excessive amount of heat energy, okay, this hair need to be lying down. Okay, when it lie down, it gives space, okay, for the heat energy to go out. Okay, why we heat energy to go out? Because we want to decrease our temperature into normal. Okay. Okay, the next one. Okay, this is the first muscle. Okay, the second effector is skeletal muscle. Okay, skeletal muscle is a muscle that attached to your bone. Okay, that attached to your bone. So what does it? What it will do is that it will contract and relax less. Okay, so the body do not shiver. Okay, badan kita tak menggeletar lah. Sebab apa? Because we know that when you are because okay, when our body shivering, this will produce more heat energy. Okay, in this situation we want to release heat energy. We don't want to produce heat energy, so that's why our body do not shiver. Okay, the next one is what happened to our arteriole. So the brain also will send to the third, okay, effector, which is arteriole. So what does arteriole do? Arteriole will do vasodilation. Okay, so vasodilation is a process where the artery will extend, okay, or will increase its diameter. Maksudnya diameter dia akan maksudnya arteriole ni dia akan mengembang. Okay, the process where the arteriole expand is called vasodilation. Why vasodilation need to occur? Because to allow more blood. Okay, so to allow more blood flow. When more blood flow can happen, so it means that more heat energy can be lost through the surrounding. Okay, because we know that blood, okay, they don't just carry oxygen, glucose, they also carry heat energy. So when the arteriole expand, more blood flow can happen. So this blood flow carry heat energy. So when the heat energy, okay, go inside the red blood arteriole, more of them can be released to the atmosphere, okay, through radiation here. Okay, the next one, sweat gland. Okay, sweat gland are also stimulated to produce more sweat, because you know that sweat is present in liquid or water. Water is a good heat absorber. So what will happen is that this sweat will absorb heat energy. Okay, this heat energy will be absorbed by the sweat and evaporate. And so this also will cool the skin. Okay. Okay guys, so this is the 4 effector that involved in physical method. Okay, the next one in terms of chemical method, what happened is that the adrenal gland. Okay, for those who don't know, adrenal gland, okay, you can find at the top of kidney. So this is our kidney, this is adrenal gland. So adrenal gland are less stimulated to secrete adrenaline. Okay, so adrenaline will make the metabolic rate decrease. Okay, and then this is thyroid gland. Thyroid gland you can find okay at the top of trachea. Okay, so thyroid gland is not stimulated. Okay, and the secretion of thyroxine is reduced. Why? Because thyroxine is responsible for metabolic rate. So when the secretion of thyroxine is reduced, so the metabolic rate will reduce. So no excess heat is generated. Okay, let's go to the next one. Okay, just now we have studied what will happen when our body temperature rise above normal. Now, what will happen when our body temperature drop? Okay, for example, when you are when you are visiting, okay, the four season country, for example, UK, US, or whatever. So for sure they have winter, right? So this will happen. So when your body temperature drop, okay, below the normal range, this will be detected by the thermoreceptor in the hypothalamus and also the thermoreceptor under the skin. So this thermoreceptor, it will detect the stimulus and produce the nerve impulse. And the nerve impulse will be sent to the brain for interpretation. Okay, when the brain interpret the information, the brain will send another impulse, okay, to the effector. Okay, so here as you can see, the effector are the same. Okay, the effector is the one that will produce response. So what will happen is that, okay, you see here, tadi kalau kita tengok effector muscle, dia do not contract. Okay, now you can see the effector muscle will contract. So when the erector muscle contract, this will make the hair become erect. Stand erect, dia akan tegang. Macam orang cakap bulu roma naik. Okay, so the consequence of having effector muscle contract is that our fine hair will be rise. So what will happen? So this will create, okay, a thick layer of air. Okay, so bila bulu roma tu menegak, dia akan trap air dekat sini. Okay, it will trap air. So what will happen is that this will prevent, okay, the heat loss, okay, from the skin, because we know that when we are having a cool weather, so it means that we have to keep our heat energy because we want to keep warm, right? So we have to minimize the heat loss from the body. So by having the thick layer of air, okay, trap, okay, between the fine hair, okay, this will act as an insulator so that it can prevent the heat loss from the skin. Okay, the next one, okay, skeletal muscle. Okay, skeletal muscle, just now during hot weather, they are not stimulated, okay, to do contract and relax, but during cool weather, okay, they will do contract and relax so that the body will shiver. Dia akan menggeletar. Why? When you are shivering, this will generate heat energy. So this heat energy will increase your body temperature. Okay. The next one is term of arteriole. Okay, so for this situation, the arteriole will do vasoconstriction. Okay, vasoconstriction is the process where the arteriole will shrink. Dia akan mengecut. Macam tadi, arteriole dia mengembang. Why? Because we know that inside the blood there is a heat energy. So when the vasoconstriction happen, so the blood flow will be minimized. So when the blood flow will be minimized, it means that less heat energy can be drawn, okay, through the skin. So with that, less heat energy is lost to the environment through radiation. Okay. The next one is sweat gland. So you see here, the sweat gland are not stimulated. So sweating does not happen. Okay, because we know that sweat, okay, it will absorb the heat energy from the body. Right now, we want to keep the heat energy. So that's why the sweat shouldn't be produced. Okay, enough with the physical method. Now we go for the chemical method. So for the adrenal gland, they are stimulated to secrete more adrenaline. So when adrenaline hormone are more secreted, okay, this will speed up, okay, the conversion of glycogen into glucose. Why? Because this glucose will be used, okay, for metabolic reaction. Okay, so more heat energy can be produced. Why? To release heat to warm the body. Okay, and then for the thyroid gland, they will secrete more thyroxine to increase metabolic rate. So more heat energy will be generated, okay, to warm the body. Okay, basically, maybe you can just remember one situation. For example, you want to remember what happened to the effector during hot weather. Okay, for the cool weather, you just change the term. For example, kalau increase, tulis decrease. Kalau dia erect, yang tu tidak erect. Kalau yang ni shiver, yang ni tidak shivering. Okay? Okay guys, so let's go to the next one. Okay, the next one is about regulation of blood sugar level. Okay, blood sugar level. So basically, there are two situations here you can see. Okay, so after meal. Okay, the after meal for sure, when you are taking a huge meal, this will make, okay, your blood glucose level will increase. Okay, why blood glucose? Okay, for those who don't know, when we eat rice, when we eat bread or whatever, so the final product is glucose, right? So glucose is actually is a sugar. So you can use the word either blood sugar or blood glucose. They are the same. Okay, so I give you one situation when you are taking a meal, a huge meal, your blood glucose will increase. Why? Because your meal have carbohydrate, right? So by having carbohydrate, it means that more glucose will be present in your blood. So after the meal, we can say that the blood glucose level will rise above normal. Okay, so when this happens, this is not normal. Okay, this is not normal. So what will happen is that, you see here, okay, so the beta cell, okay, in the pancreatic. Okay, so this is pancreas. Okay, because we know that pancreas is an organ. So for sure, it has a cell. Okay, in the pancreas, there are two types of cell you should know. The first one is beta cell, the next one is alpha cell. So what happened? So when your when after the meal, your blood glucose rise above normal. Okay, so this is not normal. What will happen is that the beta cell in the pancreas, okay, are stimulated to secrete, okay, insulin into the blood. Insulin is a hormone, okay, hormone produced by pancreas, specifically by the beta cell in the pancreas. So what will happen is that the insulin will stimulate, okay, the muscle cell to produce glucose. Okay, insulin will stimulate the muscle cell to produce glucose in the process of cell respiration. Okay, and then insulin also will stimulate conversion of excess glucose into the glycogen to be stored in the liver and the muscle cell. And the last one, in adipose tissue, the insulin will convert excess glucose into fat. So this is the outcome when the glucose is secreted. Okay, the first one is that because we know that, okay, bear in mind, insulin, the function is to convert glucose into glycogen. Why? Because we know that when the blood glucose rise, it means that we have too much glucose. So this glucose need to be converted into something else, which is specifically glycogen. So the glucose, it will convert, okay, the excess glucose into glycogen, and this glycogen will be stored in the liver and in the muscle tissue. Okay. Okay, so when this happen, the blood glucose level back to normal. Okay. Okay, this is the first situation. The next situation is that when you are fasting. Okay, when you are fasting, you don't eat any meal. So it means that your blood glucose level will decrease. So this is not normal. What happen is that the alpha cell in the pancreas are stimulated to produce glucagon. Yang ni dia hasil glucagon. Glucagon tu adalah hormon juga. Yang ni beta cell ni hasil insulin. Insulin pun hormon. Okay, so what will happen is that this glucagon stimulate the liver cell to convert glycogen into glucose. Dia tukar balik. Macam tadi insulin convert glucose into glycogen. Yang ni tukar balik daripada glycogen ke glucose. So glucagon also promote the breakdown of fat, to release fatty acid that can be metabolized, to produce energy. Sebab tu dah bila awak berpuasa, awak akan kurus. Sebab apa? Pertama sekali, dia akan tukar glycogen yang tersimpan dalam awak punya liver dan juga dalam awak punya muscle to be converted into glucose. And the next one, it also will break down the fat, lemak-lemak, kepada fatty acid. Why? Because we know that fat also can give us energy. Okay, you see here, the failure in production, secretion, and the intake of insulin by targeted cell can cause diabetes mellitus. The blood glucose level of diabetic patient is usually high and unstable after the meal. The patient also feel thirsty, tired, fatigue, and suffer weight loss. Diabetes mellitus can be controlled by insulin injection, pill that lower the blood glucose level, and a proper diet. Just now, I think this one you have studied, right? Diabetes mellitus in the presentation. Okay guys, so let's continue. So the next one, we are going to study about how our body react when there is a change in blood pressure and also the concentration of carbon dioxide in the blood. Okay, so I repeat again. So the next lecture, we are going to study how our body will react when there is a change in the partial pressure of carbon dioxide in the blood and what happens if there is a change in the blood pressure. Okay, so apa ni? Okay, kita pergi satu-satu awak tengok kat sini dulu. Okay, kita nak baca lah, kita tengok ini je. Okay, awak tengok sini. Okay, during vigorous activity, the partial pressure of carbon dioxide increase because cellular respiration. Cikgu, apa maksud partial pressure? Okay, partial pressure tu maksudnya adalah concentration. Concentration. Tapi kat sini kita tak guna terms concentration. Instead, we use term partial pressure. Okay. Okay, kalau kat sini awak tengok, during very vigorous activity. Vigorous activity tu aktiviti cergas lah. Sebagai contoh, awak berlari, bersenam dan sebagainya. Okay, during vigorous activity, the concentration ataupun the partial pressure of carbon dioxide increase because of cellular respiration. Betul lah sebab, okay, bila awak buat vigorous activity, awak perlukan lebih banyak energy, betul tak? Nak dapat energi, awak buat apa? Awak buat cellular respiration. Ingat lagi tak cell respiration ataupun respiration? Formula respiration adalah glucose plus oksigen. So dia akan hasilkan energi, water and carbon dioxide. Sebab itulah concentration ataupun partial pressure of carbon dioxide akan increase juga. Boleh faham? So awak tengok. The carbon dioxide will dissolve in the blood plasma to form carbonic acid. Okay, so when our body produce so many carbon dioxide, the carbon dioxide will dissolve in the water yang ada dekat blood plasma. Cikgu, blood plasma ni apa pula? Okay, blood, kita punya darah ni terbahagi kepada dua. Kita ada blood cell. Okay, kita ada blood plasma. Blood cell tu contoh dia tiga je. Red blood cell, white blood cell, platelet. Kalau blood plasma, yang itulah yang ada air. Yang ada air, ada nutrien, ada antibody dan sebagainya. Sebab tu dia cakap, carbon dioxide dissolve in the blood plasma to form carbonic acid. Dalam blood plasma ada apa? Ada water. Sebab itulah carbon dioxide dia akan bind with water to form carbonic acid.
Carbonic acid ni is not stable. So it will be broken down into hydrogen ion and bicarbonate ion. Boleh faham? Okay, so apa terjadi seterusnya? The pH value of blood and tissue fluid that flow to the brain decrease. Okay, pH value decrease. Maksudnya dia become acid, betul tak? Kan pH rendah kan acid, pH tinggi alkaline, betul tak? Cikgu, kenapa pH value of blood tu decrease? Sebab apa? Ada hydrogen ion. Awak belajar tak chemistry? Kalau lebih banyak H+, contohnya hydrochloric acid. Kan ada H+ ataupun hydrogen ion. So kehadiran hydrogen ion itulah menyebabkan pH dia turun. Okay. So when there are more hydrogen ion, this will drop the pH value of the blood and tissue. So tengok. The change in pH is detected by central chemoreceptor in the medulla oblongata. Okey, chemoreceptor ni apa cikgu? Chemoreceptor ni adalah reseptor yang mengesan perubahan kimia. Perubahan kimia termasuklah perubahan pH. Betul tak? Okey, chemoreceptor tu is a receptor that will detect any chemical change in the body. So what will happen? The change in pH will be detected by chemoreceptor yang ada kat mana? Dekat medulla oblongata. Dekat kepala kita ni, dekat otak kita ada medulla oblongata. Medulla oblongata ni dia ada chemoreceptor. So bila blood pH tu drop, okay, chemoreceptor dalam medulla oblongata will detect. Okay, saya nak cerita sikit. Chemoreceptor ni ada dua tempat. Pertama sekali boleh jumpa dekat medulla oblongata. Yang kedua adalah kita boleh jumpa dekat ni. Okey, dekat carotid body dengan aortic body. Ni dia cakap ni. In the peripheral chemistry in the neck. Okey, carotid body ataupun aortic body. Ni aortic body ni maksudnya aorta lah. Tahu tak aorta? Tahu kan aorta? Okay, so aorta ni dia ada banyak branch. So branch dua ni nama dia adalah aortic body. Yang ni lah akan membawa darah oksigen kepada bahagian tengkak. Sebab tu dia cakap neck. Hello? Okey, sekejap Ada masalah internet pula cikgu ni. Okay guys, so let's continue. Okay, maafkan cikgu Okay, cikgu ulang balik When the pH drop, this will be detected by chemoreceptor. Chemoreceptor ni ada dua tempat. Dekat medulla oblongata, satu lagi dekat kita punya aortic body dan juga carotid body. Aortic body ni adalah tempat yang mana kita tengok ni awak tengok ni. Aorta. Aorta tu aortic body lah. Yang kedua adalah carotid body. Carotid body ni is a blood vessel present in our neck. Dekat kita punya tengkak. Okay, so boleh faham? So apa yang akan terjadi adalah, awak tengok ni. So chemoreceptor. Okay, kita pergi kepada brain dahulu ataupun medulla oblongata. So apa yang terjadi adalah chemoreceptor tu dia. Okay guys, cikgu minta maaf tadi ada line tak berapa nak elok. Jadi cikgu terpaksa buat video baru. Okay, tak apa, sekejap Okay guys, so cikgu ulang balik So bila chemoreceptor tu
Okay, chemoreceptor. Kita ambil satu contoh lah. Kita ambil contoh brain je lah dekat medulla oblongata ni. So when the chemoreceptor in the medulla oblongata detect the change, this chemoreceptor will trigger nerve impulse. Okay, and then this nerve impulse will be sent, okay, to the ni awak tengok, nerve impulse trigger and send. Hantar kat mana? Hantar ke respiration control center and cardiovascular control center inside medulla oblongata. Maksudnya chemoreceptor tu dia akan hantar nerve impulse kepada respiratory center dan juga respiration center dan juga cardiovascular center yang berada dalam medulla oblongata juga. Maksudnya dia bermain kat sini. Okay, so kat sini ada chemoreceptor. Chemoreceptor tu dia akan hasilkan nerve impulse dan dia akan hantar nerve impulse kepada respiration center dan cardiovascular center yang ada juga dekat medulla oblongata. Medulla oblongata ni luas tau, yang warna kuning ni. Okay, so apa yang dua benda ni buat? So dia akan hantar another nerve impulse kepada effector. Kepada effector. Ni effector dia lah. Pertama sekali intercostal muscle. Ni intercostal muscle. Okay, yang kedua adalah diaphragm. Ni diaphragm. Lepas tu cardiac muscle. Cardiac muscle tu adalah muscle yang ada dalam jantung. Okay. Okay. So apa yang akan jadi? So dia maksud bila dia hantar nerve impulse kepada effector, maksudnya effector ni dia akan buat apa? Dia akan buat respon. So apa respon dia? Okay. The breathing rate, the heart rate and ventilation rate increase. This cause more carbon dioxide gas to be expelled from the lung. Breathing rate ni awak tahu kan? Heart rate awak tahu. Heart rate tu heartbeat dia lah. Maksudnya darah tu jantung tu akan pump lebih laju. Ventilation rate tu apa cikgu? Ventilation rate tu adalah proses yang mana awak inhale and exhale. Maksudnya itu maksud ventilation. Boleh? So bila kita buat benda semua ni, respon ni apa akan jadi? Lebih banyak carbon dioxide akan dikeluarkan melalui jantung. So apa jadi? The partial pressure of carbon dioxide, okay, and blood pH level will go back to normal. Boleh faham? Okay, itu saja untuk ni the regulation of partial pressure of carbon dioxide in the blood. Now we go to the last one. Okay, the blood pressure. Okay, the blood pressure in regulation mechanism. Okay, tadi kita cerita pasal chemoreceptor. Ingat chemoreceptor ni. Chemoreceptor tu adalah untuk mengesan any chemical change in your body. Kalau baroreceptor, baroreceptor is a pressure receptor. Maksudnya dia akan mengesan any change in blood pressure. Okay, awak tengok baroreceptor or pressure receptor are located in a aortic arch and carotid artery. Okay, nak cikgu nak tunjuk. Kat mana dia cakap? Dekat aortic artery. Ni aortic artery. Yang ni aortic body. Dua ni adalah aortic body. Ni carotid body, carotid artery ni yang ni. Salur darah yang ni. Kita jumpa baroreceptor. Yang kedua jumpa kat mana? Aortic arch. Mana aortic arch? Ni yang ni. Okay. Dekat aorta ni lah. So, tengok ni ya. Carotid artery is artery in the neck. Ni cikgu cakap ni. Aortic artery is the artery that supply blood, okay, from neck to the head. And this receptor detect the pressure of the blood flowing through them and continuously send impulse to the cardiovascular control center in the medulla oblongata and regulate the blood pressure. Okey, jom kita pergi kepada satu situasi. Okey, ni situasi bila tekanan darah turun. Ini situasi bila blood pressure increase. Kan blood darah kan ada blood pressure rendah sangat, blood pressure tinggi sangat. Ni lah. Okay, kita pergi kepada drop dulu. When an individual blood pressure drop
For example, there is a serious bleeding. Bila kita kehilangan darah yang banyak, blood pressure kita akan turun lah. Okay, apa jadi? So, baroreceptor in the aortic arch and carotid artery. Maksudnya, baroreceptor yang ada dekat sini dan juga dekat sini, okay, are less stimulated. Okay, bila less stimulated, apa akan jadi? The cardiovascular control center in medulla oblongata will be less stimulated. Dia less aktif lah kot. Less active. So apa akan jadi? Atrial vasoconstriction. Ni. Atrial vasoconstriction will occur. Apa akan jadi? Maksudnya vasoconstriction ni maksudnya kita punya blood, kita punya saluran darah tu akan, blood vessel dia akan mengecil. Okay, akan mengecil. Ni awak tengok. Vasoconstriction tu maksudnya blood vessel akan mengecil. Mengecut. Okay, this add resistance to the blood flow in a bloodstream and stronger constriction of cardiac muscle occur. Untuk apa kita buat benda macam ni? Untuk menaikkan blood pressure. Sebab blood pressure kita kan rendah kat sini. So in order to make blood pressure increase, vasoconstriction will happen. So the blood pressure return to a normal range. Boleh faham? Okay, this will happen when your blood pressure increase, especially when you are doing vigorous activity. So baroreceptor in the aortic arch and carotid arch are stimulated. Awak tukar je ayat dia. Less stimulated, ni more stimulated. So okay, the cardiovascular control center in a medulla stimulated. So apa akan jadi? Tukar je lah, vasodilation. Vasodilation tu macam mana? Vasodilation maksudnya saluran darah ni akan mengembang. Bila mengembang apa jadi? Reduce the resistance of blood flow in a bloodstream. So weak constriction of the cardiac muscular occur. Cardiac muscle ni adalah okay, cardiac muscle ni adalah muscle yang kita jumpa dekat jantung lah. Okay, so pressure akan turun. Bila blood pressure turun, the blood pressure return to a normal range. Okay. Okay, if you want to copy this note, you can pause the video and you can. Okay guys, so let's continue. Okay, the next one is about tropic response. Okay, so let's go. So tropism is a response to a stimulus. Okay, ataupun you can say tropism is a plant response. Sebab kita nak baca pasal plant It's a plant response towards the stimulus. Stimulus to it could be anything. Okay, it could be any change in the environment. But right now we are focusing on two type of stimulus, which are light dan juga gravity. Okay, kalau pasal light we call it as a phototropism. Kalau pasal gravity kita sebut sebagai gravitropism. Okay. So what you should know is that, okay, so at the tips of the shoot ataupun root, okay, at the tip of the shoot, okay, so there is a production of auxin. So tengok ni. Auxin is a plant hormone that is chemically control the growth at near the tips of the shoot. Sebab apa? Dekat tip of shoot ni lah auxin dihasilkan. Okay. It is produced in the tips and spread through the plant from there. The distribution or spread of auxin is unequal in response to a light and gravity. Ini kita akan baca detail sekejap lagi. Okay, the auxin will stimulate, okay, the cell elongation in the cell just behind the tip. So maksudnya auxin will stimulate the cell growth. Dia akan memanjang. Okay. So if the shoot tip is removed, no auxin is available and the shoot may stop growing. So we know that tips of the shoot is the place where auxin is produced. When we remove the tips of the shoot, okay, it means that no auxin is produced. No auxin, no growth. Okay. So kita, sorry. Apa ni? Okay.
So now we know that there are two stimulus that we are going to investigate, okay, which is about phototropism and geotropism. Bear in mind, phototropism ada dua, positif, negatif. Gravitropism pun ada dua, positif, negatif. It's either, okay, so we go one by one, okay, kita pergi kepada phototropism. So phototropism has two, positive phototropism and negative phototropism. Okay, kita pergi kepada positive tropism dulu. So okay, so when a shoot tip is exposed to the light, more oxygen accumulate, okay, on the side that is in the shade that Allah susah saya guna sebut. Then the side that is in the light. So nak tengok sini. So this is the tips of the shoot. Okay, so this is the place where oxygen is produced. But bear in mind, oxygen ni dia ada satu karakteristik, which is it will always stay away from the light. Dia tak suka cahaya, so dia akan menjauhi. So what happen is that when the production of oxygen is done, so the oxygen will stay away from the light. Okay, dia akan pergi kat kawasan sini. Sebab apa? Because this is the direction of sunlight. Okay, so mestilah kawasan sini je yang kena cahaya kan, kawasan sini tak kena. So that's why the oxygen will accumulate more in the shaded area. Okay, so what happened? Tengok. Okay, this stimulate the cell to elongate faster on the shaded side. So they should bend towards the light. So kalau tengok, okay, the growth will happen faster in this particular area. So what is the result? The result is that the shoot will bend towards the light. So bila dia bend towards the light, which is our stimulus, we call it as a positive phototropism. Sebab apa? Dia grow towards the stimulus. Dia grow towards the light. Ni faham? Okay, seterusnya adalah kita tengok negative geotropism. Still in the shoot. Okay. So kalau awak tengok kat sini, ni cikgu explain inilah. Okay, this is shoot. Okay, bear in mind, shoot will always grow upward. Mestilah dia bergerak ke atas kan, takkan dia gerak ke bawah. So it show negative gravitropism. Okay, so when this happen, this oxygen, okay, dia akan accumulate at the lower side of the tip. Ni awak tengok ni. At the lower side of the tip. Sebab apa? Semua benda mesti akan jatuh ke bawah. Sebab apa? Ada daya tarikan graviti. Okay, ada daya tarikan gravity. So what will happen is that this will, tengok ni, this stimulate the cell of the lower side to elongate faster than the upper side. Okay, so apa yang terjadi? So the shoot will bend upward. Dia akan bergerak ke atas. So bila bergerak ke atas, dia adalah negative geotropism. Sorry, negative gravitropism. Kalau dia bergerak ke bawah macam root kan dia grow downward kan. So root positive gravitropism. Tapi shoot, okay, dia negatif. Tapi kalau in term of phototropism, shoot ni dia akan tunjuk positif. Kalau root negatif phototropism. Okay. Okay, the next one. Okay, awak tengok ni. Okay, synthetic plant hormone can be used as a weed killer. So selective weed killer, okay, have been developed from auxin. They disrupt the normal growth pattern of a certain plant, okay, which kill them. So they leave grass and crops untouched. Okay, so 2,4-D is a synthetic plant hormone that is example of selective weed killer. So macam mana kita boleh guna plant hormone ni sebagai weed killer is that because kita tahu dalam weed killer ni dia ada auxin. Fungsi auxin ni adalah untuk stimulate the growth. To stimulate the growth. So apa yang kita boleh buat adalah, so bila when we put selective weed killer on the grass for example, sebab kita tak nak rumput, kita nak grass kan, ataupun weed kan. So apa terjadi adalah when we spray the weed killer on the weed, okay, so maksudnya weed tu dia akan dapat auxin, right? Cikgu, kalau auxin ni dia bagus lah kan untuk stimulate growth. Awak kena ingat, when we use excessive amount of auxin, it will produce unusual growth. Maksudnya pembesaran dia tu menjadi lebih besar. Bila pembesaran dia lebih besar daripada normal, dia ada tendensi untuk mati. Sebab apa? Sebab they are not capable to bear with the unexcessive growth. Okay. Okay, tropism will allow plant to react to the surrounding. Okay, by responding to the stimuli of the environment, plant increase the chance of survival. For example, by growing towards the light, the plant will increase the amount of the light to do photosynthesis. Okay, itu sajalah untuk tropism. Okay.